Okay, write down today topic work, power and energy. Write down today topic work, power and energy. Work, power and energy. Here very simple lesson, directly target for part A action, part A applied paper action. Okay, consider here a particle, so given a force P, then corresponding to that, let's say displacement x here. Here displacement x, initial position A, end position B. So because of that motion, because of that force, there will be a work will be done. Okay, then that work we say force into displacement along the force into displacement along the force. Then W equal P times X. Here usually measured by Newton meters or joule. Here W equal P times X. Here this is we call work. Then actual definition of this work, consider here force is a vector P and let displacement simple x vector x. Take this angle theta. Then actual definition of work given by vectors, dot product. Then work equal P dot x. Here that is given by P dot x. Modulus P, modulus x cos theta. Modulus P, modulus x cos theta. Then force into displacement along the force. Force into displacement along the force. That is we call work. We call work. Okay. First write that one. Then you see power. See power. Here we say work done per unit time. Per unit time. Then W equal P times X now. Then differentiate this. dW divided by dt, dPx divided by dt. Then we denote this one by H. Here P constant, take it outside. dx divided by dt. dx divided by dt. Then displacement divided by time, we say velocity. Then H equal PV. Here H equal PV is the equation. Formula. H equal PV is the formula. Then here you consider here a vehicle which has engine. To move this engine, there must be power given. There must be power given. That power we say P. And here corresponding power. Here force P. H equal PV. Okay. By the engine, that power will generate. Then H equal PV. Then usually H measured by watts. Watts. Then there's another 1 horsepower. 1 horsepower means for 746 watts. Here just unit conversion. 1 horsepower equals 746 watts. Then H equal PV. This is we call power. Work done per unit time. Work done per unit time. Okay, put that on as well. This power P, we specially say tractive force. Tractive force. So that tractive force has generated by the engine. The tractive force has generated by the engine. Okay. Then next one, energy. Energy. Then you consider here an object with mass m with velocity v, which at height simple h from E0 level. So here this has kinetic energy that is half m v square. Then potential energy, gravitational potential energy mgh. Here that is energy. Okay. And further, you consider a spring. So here let this natural length L, say extension x. Then here there will be elastic energy will be stored. Then elastic energy delta EV say half kx square. Here elastic energy, k means spring constant. Then further we can write delta E half lambda divided by Lx squared, lambda divided by Lx squared, same relation, or you can write delta E equal half Ya divided by L x squared. Okay, this can be string or spring, whatever it is, okay. Here this is spring or string. So K we call spring constant, lambda we call modulus of elasticity. Then Y call Young's modulus. Y we call Young's modulus. So usually in mathematics we consider about this. Half lambda over L x squared. Okay, that is stored elastic energy. Here all are given by elastic energy. Elastic energy. Okay, better write them. That is about energy. Okay, then finally here there's special thing, that is unit conversion. 1 ton equal 1000 kilograms, and 1 to 100 inclination, 100 is to 1 inclination. Inclination is here, that represent here angle theta, sin theta 1 over 100. Then further, a constant velocity or maximum velocity that represent acceleration 0. Acceleration equals 0. So constant velocity say acceleration 0. Maximum velocity also say acceleration 0, because further we can't increase velocity. Here you better to put this note. That's all about work, power, energy theory part. Take your tutorial. Page number 1, 2005 A-level question. Start it. Page number 1, 2005 A-level question. Start doing it. First read well. A lorry of mass capital M kilograms with its engine working power h kilowatts has maximum speed u. Has maximum speed u mean acceleration 0 on a horizontal road with the engine working at the same power. Maximum speed of the lorry up a road of inclination alpha to the horizontal is v. If the resistance is unchanged, find the value of h. So here this case, usually we have one equation, h equal pv. H equal pv equation, we have only one equation. Then p mean tractive force, h mean power. Then with that one you can apply Newton's law, F equals ma. And also you can apply equation of motions. V equal u plus f at, s equal ut plus half at square, v square equal u square plus 2s. Likewise, you can apply all. Then first case, you better to sketch diagram first. First sketch diagram, 2005. Here lorry of mass capital M in kilograms, say mg. Working at power, it has engine, its power h kilowatts. Then multiply by 1000, convert into watts. It has maximum speed u. Maximum speed. Therefore, it says that acceleration 0. So here power given, no? Then there will be tractive force P. You better to mark that tractive force P. and again there will be resistance R. Then you can apply H equal PV formula first. H 1000, H tractive force P, velocity given U, then P equal 1000 H divided by U. 1000 H divided by U. Thereafter, use horizontally F equals ma. We have specially H equal PV and F equal ma equation with equation of motion. P minus R, mass capital M into acceleration 0. Then R equal to P. 1000 H divided by U. Then R value 1000 H divided by U, resistance. Then against same resistance it moves. Against same resistance it moves up a hill. Inclination given alpha. Here P, capital Mg, resistance R. Resistance R. Now here velocity V, maximum velocity. Therefore acceleration 0. Then you mark new tractive force P1, because tractive force can be differ. Then use this F equals ma. Then P1 minus R minus mg sin alpha equal capital M times acceleration 0, because V is the maximum speed V. Then P1 R plus mg sin alpha. Then R already known, 1000 H or U. mg sin alpha. mg sin alpha. Then use H equal PV equation. Now power can be different, no? Tractive force P1, 1000 H over U plus mg sin alpha times velocity V. V. Here new power. New power. Time to time power can be changed, okay? Same H, same power කියලා තියෙනවානේ, same power H. Tractive force P1 V 1000 H, 1000 H divided by V. Then substitute here 1000 H over V, R mean 1000 H over U equal mg sin alpha. Then find H value. Find H value. Mg sin alpha divided by 1000. Here 1 over V, 1 over U. Here H value. Mg sin alpha 1000, 1 over V minus 1 over U. Right. 2011 question started 2011. Total mass of the cyclist and his bicycle m kilograms. When he rides directly up a road, inclination at an angle alpha to the horizontal at a constant speed v against resistance r. He works at constant rate of h kilowatts. H kilowatt. He moving up a hill. Here capital M kilograms, inclination alpha, mark resistance R, there will be tractive force P. Resistance R given, then velocity V, constant speed, we are given constant speed. Therefore say acceleration 0. Then upward use F equals ma, P minus R minus mg sin alpha, mass into acceleration 0. Then tractive force equal R plus mg sin alpha. Then use H equal PV formula. Then power H P R plus mg sin alpha, that instant velocity V. That instant velocity V. H equal R mg sin alpha times V. R mg sin alpha times V. No? Okay. Then you start from 2014 and continue up to 2021. 2021. Start from 2014. 2014, a vehicle of mass M pulls trailer of same mass light inextensible spring by light inextensible spring. Here the vehicle and here the trailer. mg same mass, mg along a straight track. Resistance of motion of the vehicle, capital R given, and here 2R given. Here there will be tension T, then here power P kilowatts, and mark tractive force P1, here tractive force. And vehicle moving with speed V. But here that is not given constant velocity or maximum velocity, no. Therefore, definitely there can be acceleration. Okay. Then you better to mark acceleration A. Acceleration A. Now consider system. This way F equals ma, tractive force P1, total resistance 3R, total mass 2m, acceleration A. Same time source H equal PV, power given P kilowatts, then here 1000 P, tractive force P1, that instant velocity V given, then P1 equal 1000 P over V. Then put it here, 1000 P over V, TR 2m A. Then find acceleration m, divide by 2m, 1000 P divided by 2m V, 3R divided by 2m. Here acceleration. Thereafter you consider only about trailer, use F equals ma horizontally, then tension T, mass capital M, here T minus 2R equal ma, T minus 2R equal ma, and tension equal to R plus ma, 1000 P over 2 mV, R divided by 2 capital M. Here it is. Now you simplify this one. Simplify. And 2R 1000 P divided by 2V, 3R over 2. And here R divided by 2. 1000 P divided by 2V, take 1 over 2 outside, R plus 1000 P divided by V. That is in newtons. That is 2014. Do up to 2023. Continue. Okay, then 2015 A-level question. A lorry of mass capital M metric tons. Consider metric ton both same, 1000 kilogram. No? Moves with constant velocity u along straight level road. Here it is. Velocity u constant. Constant velocity. Therefore, say acceleration 0. Then mark tractive force P. Then its power given H. H kilowatts. Then 1000 watts. Then resistance R. Resistance R. Then use F equals ma. P minus R equal capital M mass into here capital M tons, no? 1000 in kilogram weight. Acceleration 0, then P equal to R. Resistance and tractive force same. Then use H equal PV. H equal PV. H kilowatt 1000. H tractive force P, that instant velocity u. Then P value 1000 H divided by u. Then R value same. R value same. Thereafter, it says that move along a track. Straight rod with inclination alpha to the horizontal. Now here it is now. Capital mg, m into 1000 g. Then new tractive force mark P1, resistance same resistance, say R. Then by this one, therefore resistance R equal 1000 H divided by u, no? 1000 H divided by u. Then you can use F equals ma. Show that the maximum speed of the lorry. So consider V maximum speed. Maximum speed. Therefore acceleration 0. Here use F equals ma. P1 minus R minus m into 1000 g sin alpha 1000 m times 0. Acceleration 0. Now P1 R plus 1000 m g sin alpha. R mean 1000 H divided by u. 1000 H divided by u. 1000 mg sin alpha. Here tractive force. Now at that time its power 2h kilowatts. 2h kilowatts. So we have to find velocity v. Now thereafter use h equal pv formula. Finally use h equal pv formula. Then 2h kilowatt 1000 P1, that instant velocity v. Then v equal 2000 H divided by P1. P1 means this. 1000 H divided by u. 1000 mg sin alpha divided by sin alpha. Then cancel 1000. 2HU H plus mgu sin alpha. Mgu sin alpha. Always we need to manage H equal pv, F equals ma and equation of motion. Okay. 2016. So when you complete these questions, you can complete remaining past paper questions. Then go to remaining past paper question, then complete. 2016, a car of mass m kilograms moves along a straight level road. Capital Mg, resistance R. At that instant, moving its speed v. Here mark tractive force P, that instant velocity v, acceleration A. Then use F equals ma, P minus R equal ma, then P equal R plus ma. Then use H equal PV. Then we need to find power. Tractive force R plus ma, that instant velocity v. Here power. R plus mav. The car then moves with constant speed v1. Constant speed v1. That means acceleration 0. Against a resistance of same magnitude r up a straight road inclination alpha to the horizontal. Now that moving up with inclination alpha, let this power P1, capital Mg, resistance R, same resistance. Now velocity V1 constant, therefore acceleration 0. Then use this way, F equals ma, P1 minus R minus Mg sin alpha equal m times 0. Then P1 R plus Mg sin alpha. Then use H equal PV. Then same power H. H mean R ma V. We know that. Then tractive force P1 R plus Mg sin alpha times V1. Then subject V1. R plus MAV over R plus Mg sin alpha. R plus Mg sin alpha. Continue. Continue. 17, a truck of mass capital M towing a car of mass capital simple M. Here simple mg, here capital Mg, here there's an engine, light inextensible string, mark tension T, the resistance of the motion of the truck and the car, lambda m, here lambda capital M, here lambda simple m resistance, mark tractive force P, lambda positive. At a certain instant, the power generated by the engine, capital P, then power, capital P kilowatts, 1000 P watts. The speed of the truck V, here velocity V, speed V, but acceleration, there can be acceleration because that is not maximum velocity or constant velocity. Therefore, you use H equal PV now, 1000 P, tractive force mark P1, that instant velocity V, then P1, 1000 P over V. Then use F equals MA, full system. Then P1 minus lambda M resistance, lambda capital M resistance, total mass M plus M, its acceleration say A, because we don't know exactly whether it has acceleration or not. But anyway, the velocity changes not given. Therefore, you take there can be acceleration. Then P1, 1000 P over V minus lambda M plus M, M plus M A. Then acceleration 1000 P over V M plus M minus lambda. Acceleration. Show that the tension of the cable, now we need to find the tension. Now consider only vehicle car, take only car, use F equals M. T minus lambda M equals simple M A. Simple M A. Then T equal lambda M plus simple M A. 1000 P over V M plus M minus lambda. Then 1000 M P over V M plus MV. M plus MV. Okay. In 2018 question. Question, a car of mass 1200 kilograms moves with the engine shut off. So engine shut off means no tractive force. Down straight rod, inclination alpha to the horizontal. Here alpha, here the car 1200 G, then there will be resistance R, then alpha sin alpha 1/30 inclination. G10, then G10. Now that is in Newton. Find resistance. Use F equals ma. Okay. 1200, 12,000 sin alpha minus R mass 1200 into acceleration. Acceleration certain constant speed, no? And acceleration 0. Acceleration 0, certain constant speed. Then R equal 12,000 sin alpha 1/30. Resistance 400 Newton. Find the power of the engine thereafter. When the car ascends the same road. So now it ascend 12,000 Newton weight, resistance R, tractive force P, new tractive force P. That instant acceleration 1/6 meters per square seconds and velocity 15 meters per second. Alpha. Then use F equals ma, P minus R minus 12,000 sin alpha 1200 times acceleration 1/6. Simplify. P, R mean 400, take all the other side. 400, 12,000 sin alpha 1/30 plus 200. P 1000. Then use H equal PV. H equal PV. Tractive force 1000, that instant velocity 15. Then 15 kilowatts. 15 kilowatts. Continue. Then 2019, car of mass capital M, constant power capital P moves downward along straight road, inclination alpha to the horizontal, with a constant resistance R. Here alpha inclination, mg, resistance R. That instant acceleration A. Here mark tractive force P, say P1, power P kilowatts, 1000 P. Find the velocity of the car at that instant. Okay. Then downward f equals ma p1 minus r plus mg sin alpha. Capital M times acceleration a. Then p1 equal ma plus r minus mg sin alpha. Then use h equal pv. H equal 1000 p. Tractive force ma plus r minus mg sin alpha times v, that instant velocity v. Find the velocity of the car that instant. V equal then 1000 p over ma plus r minus mg sin alpha. Velocity at that instant. Deduce the constant speed with the car can move along the road. Constant speed. So we need to deduce this. Then constant speed, acceleration 0. Therefore a 0. Then constant speed v equal 1000 p over, take a 0, r minus mg sin alpha. R minus mg sin alpha. Continue. Okay. 2020 A level question. A car of mass 1500 kilograms, resistance 500 Newton, power 50 kilowatts, mark tractive force P, H equal PV, then 50 times 1000 PV with speed 25. P equal 2000 Newton. At that instant, engine of the car is turned off. Now engine of the car turned off, that means tractive force gone. Find the speed of the car after 50 seconds. From the instant the engine was turned off. So at that time velocity V, at that time velocity 25, initially 25. Now it has only resistance 500. Use F equals ma to find retardation. Minus 500 mass 1500 A. A equal 1/3 minus retardation. Then we need to find velocity. Then V equal U plus AT. Initial velocity 25, here 1/3 T after 50 seconds. 50. Then 25 over 3 meters per second. 25 over 3 meters per second. එතනදී acceleration එක ගන්නක් තියෙනවානේ F equals ma දාන්න. Acceleration 2000 minus 500 1500 A1. Yeah, acceleration A equal 1 meters per second. Meters per square seconds. Here acceleration. Okay. Then 2021. A car of mass m moves upwards with constant acceleration along the straight road with inclination sin inverse 120. Sin inverse 120. Constant resistance R. Then 36 kilometers per hour in meters per second, 36 into 1000, 3600 meters per second, then 10 meters per second, then 72 kilometers per hour, 20 meters per second. So it takes displacement 500 meters to reach that velocity. Obtain sufficient equation. Now need to find them. obtain sufficient equation to determine the power exerted by the car when its speed 54 kilometers per hour. 54 kilometers per hour. Okay. Then here V square equal U squared plus 2AS formula. V here 20 square, 10 square minus 2, acceleration take A, displacement 500. Then here 400, 100, 300 equal 1000 A, 300, A equal 1 over 3 over 10. Here acceleration 3 over 10 acceleration. Then when its velocity 54 kilometers per hour, 54 kilometers per hour. Then here 15 meters per second. 15 meters per second. Then mark tractive force P. Then use F equals ma, P minus R minus mg sin alpha equal m, acceleration A. Take acceleration A. Then A value 10 over 3, no? Here first equation, second equation, use H equal PV now. Then H equal P, here find P value, R plus mg sin alpha plus ma. A mean 3 over 10. That instant velocity 15 into 15. Here watts. That is the power of the engine. 15 into 15. Okay, then 2022 A-level question. 2022 A-level question. A car of mass 1,500 kilogram working with constant power 80 kilowatts moves on horizontal road against constant resistance. Here tractive force P, resistance R, acceleration 2. Use this as F equals ma, P minus R 1500 A mean 2. Then P minus R equal 3000, first equation. When it moves with speed 20, now this time velocity 20. Then use H equal PV. Then H equal 80 times 1000, P, that instant velocity 20. Then P equal 4000. Therefore, R equal 1000. R equal 1000. Obtain equation sufficient to determine the acceleration of the car. Now inclination alpha, sine inverse 2 over 3. Sine inverse 2 over 3. With speed 8. Here 8. Then there can be acceleration A. Mark forces here. 1500 G. Newton. Mark tractive force P1. Resistance R. Same resistance, same power. Then use H equal PV. H value 80. 1000. P1 velocity 8. Then P1 equal 10,000 Newton. 10,000 Newton. F equals MA. P1 minus R minus 15,000 sine alpha equal 1500 A. Now P1 known, here AR, R known, P1 known, R known, you can find A, can obtain A. Here we need to get only sufficient equations now. Then sufficient equation determine A. This is enough. Okay, then start 2000 Euler question. 2000. Okay, 2000 A level question. An engine working constant power 500 kilowatts, pulling up with inclination 1 in 196. Then sin alpha 1 over 196. Two 2.5 10 to the power 5g. Tractive force P, resistance R, speed 24, 24 kilometers per hour. Acceleration 0.2, meters per square seconds. Then H500, 500 into 10 to the power 3 watts. V equal 24. V equal 24 into 1000, 3600. 20 over 3 meters per second. Okay, then H equal PV, 500 in 10 to the power 3 PV. Then P equal 75,000 newtons. Then use F equals MA, P minus R, 2.5 G, 5 times 10 to the power 5, G mean 10, sin alpha, mass into 2.5 10 to the power 5 into acceleration 0.2. $75,000 R, here 25 10 to the power 5 sin alpha 1 over 196, here 9 G equal here 2.25 50 10 to the power 3. Okay, then here 25,000, 25 10 to the power 5 G 9.8, 25 10 to the power 4, 98, 196, here 1, 2, 0, equal R. $25,000 over 2. Newton. 25,000 over 2. 12,500. 12,500 Newton. රෙස්ටාක් අරගෙන ඉතිරි ටික කරමු. පොඩි රෙස්ටාක් ගන්න.